Hi, welcome back to the probability section. That section 7b is combining probabilities. Well, first, let's see the AND probability, like the probability of A and B, right? The probability of A and B. That's first is independent events, right? Two probability that A and B or A and B and C for the independent events. Right? See. Two events are independent if the outcomes of one does not affect the probability of the other event, right? So which means they not affect each other. Right? Consider two independent events, A and B, with individual probability of A and the PR of B. The probability that A and B occur together is PR of A and B equals PR of A times PR of B. Right, sometimes in your notation, you will see the probability of A and B, right? That is the intersection, right? That is the intersection. If you not see the word and, that is an intersection notation like that, right? And it's equal to A times probability of B, right? And this principle can be extended to any number of independent events, right? And let's see, right? The example, three independent events, A, B, and C, that can be extended to multiply it together, right? So the notation also can be written as probability of A and B and C. Right? It is also equal to that. Right? The notation of AND could be written as the intersection. Right? That's also commonly accepted in the general world, right? In the general probability idea, right? So for the idea of independent events, let's see. Right, suppose you toss three biased coins with probability of getting ahead when toss is 0.58, right? So you have three biased coin, and the probability of getting ahead is 0.58. I don't know how it's shading that way, but yeah. Three biased coin. So what is the probability of getting three tails? Right, so which first of all, we get the probability of head is 0.58, right? Apparently, the probability of getting a tail from each coin, that is its opposite. Right, in other words, it's complement. Right, that's 42% of chance that a coin lands on the tail. Right, so what is the probability getting three tails, right? So what it means is the first is a tail, and second is a tail, and the third is a tail, right? And the one coin has a tail doesn't affect each other, right? The second or the third. So that is the probability of first is a tail times the probability of second is a tail times the probability of the third is a tail. Right, simply as what? 0.42 times 0.42 times 0.42. And multiplication can be written short as the power if you have same number multiplied together. So we have 0.42 raised to the third power, that's 0.074088. And if you want round to through 4 digits, 0741. Right, so what do we have? what we have is, well, even for a biased coin, right, it will be 42% of the likelihood to get the tail. That will be very impossible, right? Only 7% of chance to get, right, if you want, you could put 7.41%, right? Only 7% of the chance to get the, all of the three coins are tails. If it's a unbiased coin, that's 50-50 chance, you get 12.5%, right? Still not that big. All right, let's see the next one. Well, independent events, that's all are same, right? Just multiply all the probability together. Right? For the dependent event, that one may affect each other. The dependent event of outcomes, that one of the probability affects the other probability, right? Affects the probability of the other event. Dependent events A and B occur together, that's probability of A and B equal probability of A times probability of B given A, where the probability of B given A read as, well, the probability of B given A. That means the probability of event B occur given the occurrence of event A. All right. It sounds tough, but let's see. Right? All right. So the drug screening result we have seen before. And what? That subject using drugs, subject not using drugs, positive and negative, total of row 950 and for 950, total of column, positive, negative result. And what we say? Use the only 50 subjects use drugs, right? Just focusing on those 50 subjects use drugs. If two objects are randomly selected with replacement, right here with replacement is most important thing with replace. So you take the subject and put it back. What is the probability to get both negative subjects? Right, so negative, there are 6 of them, right? Focusing on that, that's 6 of the negative subjects from the 50, that's 44 positive subjects from the 50. So the first one you select, of course, nothing trouble, right? That's 6 of the negative result you select from those 50. Then the step 2, you want to select your second negative subject. And you put it with replacement. So before that's 6 subjects, total 50, you do what? What you do? What you do is take away 1, right? But you put it back. So remain the same, right? Nothing changed. So this change remain the same, that you put it back, right? With replacement means put it back. So still the second step, you still have what? Still have 6 negative results. You still have 15 total. So that's still 6 out of 50. Right, so our first trial, that is 6 negative, 15 total. On the second trial, you take out 1, you put the person back, or you put the subject back. You still have 6 negative. There are 15 total, you take out 1 for the first selection, but you put it back, right? That's the thing called with replacement. So still have 50 to be chosen, right? So 6 over 50 times 6 over 50, you just use calculator. You don't have to show me the simplification, right? That's 0.0144. Right. And then the second question say the 2, let me use another color, yeah. The 2 subjects are randomly chosen without replacement. Probability that the first subject First subject is a positive test result. Second subject is a negative test result. All right. So first subject is a positive test result. So that's positive deduct by 1. So we get 44 possible to be chosen out of 50, right? So after being chosen, but we don't put the person back or the subject back, that's going to be 43 subjects for the positive result, 6 subjects for the negative test result, and total 50 subjects. Right, then step 2. The second trial to get the negative result, that will be 6 persons to take out. And from that 50, since we took out 1 from the first step, now we have 49 only, right? So the second result will be 6 out of 49 to choose, right? So be less confused, we get rid of that, right? So the first step, after the first step done, right? So this one shows is after the first step. So you can see more clear, right? After the first step, that will be only 43 subjects. That is only 49 in total, but the negative is still 6, right? So when we select 6 negative subjects to be selected, that only 49 to be chosen, right? So the first step, the part A says what is the independent, right? Since we put the subject back, the likelihood to select 2 negative results, they are independent trials, right? Because you put it back. But the second part, the part B, you actually take out the person or take out the subject, then the likelihood actually affects by your work done, right? So 44 over 50 times 6 over 49. Right, that's 0.1078. All right, 775 goes to 78. Okay, so that's the drug screening test. Right, the next one. So 3 persons must be selected for a jury duty. Right? 3-person jury selected at random from a pool of 12 people that has 6 men and 6 women. Right, 6 men, 6 women. What's the probability selecting all female jury? Right, jury. So we need to select 3 persons, right? So, and 3 of them are female. So we just selecting from what? From women. So first, that's let's just use the letter to represent the female, right? F. So first is a female, and second is a female, and the third is a female. So what is the likelihood that first is a female? The first is a female, that's 6 women to be chosen out of 12 people, right? That's its likelihood. And then the second step, after the first step, the women decrease by 1, that will be 5 women. 12 people decrease by 1, that's 11, right? That's the first step. But the second step, right? Now you see there are only 5 female in this team, right? In this group to be chosen from those 11 people, 6 men, whatever they are, right? Because they want to choose all women, all female. So 5 female out of 11 is what they want to select. That's our step 2. But after the step 2, the women number is decreased by another 1. So that's only 4 women in the group. That's total people also decreased by 1. So that's only 10 people in the group. Then finally, the third step. Right? So the third step will be chosen from 4 women out of 10. How many remains? We actually do not care about that afterwards, right? Because that's just 3 persons need to be chosen. Right, so first that's 6 women to chosen out of 12. The second, since it's decreased by 1, right? Of course, you cannot select the same person. That's considered as just 1 person, right? So you need to select a different person. So you need to hide the person somewhere else, right? When you're taking that out. So that's only 5 persons remaining out of 11 persons, right? After the step 2, that will have only 4 persons, 4 women, 4 female remaining, and 10 persons in the total. So the way you can select a women would be 4 out of 10. Right, then finally, 6 over 12 times 5 over 11 times 4 over 10. 0.0909, right? Only 9.09%. Right? Only very low percent to get all female jury, right? Like all men jury, that will be same, right? Since they have same amount of men. Okay. Right, so that's about the jury. So step by step, it makes sense, right? I believe. Then I'm getting a little harder, right? The cards. You can try to pause the video, right? To see how the deck of cards is actually working, right? Two cards chosen randomly. Probability to get the second card is an ace. Given that the first card is an ace, right? They're not asking for step by step, but just asking for the conditional probability, right? It is just asking for, well, the probability that the second card is an ace, given that the first card is an ace. Right, so we have the deck of cards here, right? There are 4 aces out of those 52 cards, but we just randomly chosen 1 card, right, from the 4. And then if your first card is an ace, whatever it is, right? So that's what happens, right? You can pause the video and we'll go back. Okay, I believe you have tried. So let's see together, right? That are what? 4 aces, but your first is already an ace. What that means? That means after your first card is an ace, that means what? There are 51 cards. Since you chose 1 already, remains. In the deck of cards. And what? 3 aces, right? Because there was 4 aces in the deck of cards, but now that's only 3 aces because whatever one you chosen out, that's only 3 left over, right? That's only 3 aces remains. So if you want the second pick to be an ace, that will be what? That will be 3 aces to be chosen out of 51 cards. Out of 51 cards. So 3 out of 51, if you want, that's 0.0588. Right, that calculator can express as a fraction. Simple fraction, that's 1/17, right? You can express your previous result as fraction as well to see what's going on, right? But not necessary to simplify it. Okay, so that's pick two cards. Oh, well, that's all the question about the end, right? So probability is hard. That different word problem, you need to analyze your question very clear, right, of what you're gonna do with it. So that makes the probability question extremely hard. And maybe I put my handwriting a little bit better, right? There are. Okay, a little bit better. All right, hopefully you can read it. Right, then the next one is either or probability. That's non-overlapping events. Before is the and probability. That is called the intersection. Intersection events. Right? Intersection written as the upside down U look like. Right? And either or all probability, that's the union of events. I should put intersection of events. No matter they are independent or what they are intersection events, right? Independent, just they don't affect each other. Similarly, the union of events. Two events are non-overlapping. We have like non-overlapping events or something called the mutually exclusive event if they cannot occur together. Like for those events cannot occur together, they affect each other, right? When one occurs, the other cannot occur. That's kind of effectiveness. That's kind of effect, right? Cannot affect each other. I mean, cannot occur each other. That's kind of effect. The probability of mutually exclusive event or non-overlapping event, in other words, A and B, either occur, yes, A or B occur, that's just their sum. Right? Or we could write is the union of A and B occurs equals that, right? The union. The principle can be extended to number of mutually exclusive event, right? To any number, for example, either A, B, or C occur, they are mutually exclusive. That will be just the sum of each one, right? Or we written as the union of A, union B, union C, right? That's equal to the sum. Right. So suppose you're rolling a simple die and getting a 2 and getting a 3 cannot occur together, right? So what's the probability, right? Probability of the x equal 2 or x equal 3, right? Cannot occur together. So that will be the likelihood you're getting a 2 plus the likelihood you're getting a 3. That's 1/6 likelihood to get a 2. 1 out of 6 likelihood to get a 3. So we get 2/6. And that's what? 2/6, that's 1/3, that's 0.3323, right? Right, you can write the OR as the union symbol, right, if you want to. But that is too easy, right? That is easy enough. You just determine what are non-overlapping by yourself, right? By reading it, and the union, just put it A x equal 2, union x equal 3. Either or with overlapping event, that's Overlapping means it can occur together. They could occur together. Then events will be either occur or together. Right, that I think is that getting from the book, but it's a little off, a little wrong. That is actually the overlapping events A and B either occur or occur together is probability of A and B. I mean, A or B equals the sum, take away the intersection part. Right, so what happens is what? Is we have events A and events B, right? So when we have the probability of A occurs, that contains the A and the middle intersection part, right? And when we have the B occur, that's B and the middle intersection part. So what happened? When we add the parts together, right? That's the middle overlapping part is actually added twice. So therefore, to be accurate, we need to, or to be, go back to what it's supposed to be, we need to take away one of the overlapping part, right? So that's what it has to be done. All right, add it twice in the middle. That's what is make the trouble, right? So to make it correct, just subtract another one, right? Or you can write it as A intersection, I mean, not the intersection, union. Put the highlight color back, put the color back, okay. Join it, union for the overlapping. That is the either probability, take away the extra overlapping part, right? Take away the extra overlapping part. So let's see an example, right? Take away the extra. The sum of each one, take away the overlapping. Let's see, one subject randomly selected, that's still the same remote, I mean, still the same drug test. Right? What is the probability selecting subject has a positive result or uses drugs? Right? Positive result or uses drugs. That highlight is a little not great, right? Positive test result or uses drugs. Right, so if intuitively we can see positive result, intuitively, the likelihood of positive result or uses drugs, that is what? Out of 1,000 people, right, 1,000 subjects, that 44 has positive result, 90 of them has positive result, but uses or no use drugs. 44 uses drugs and 6 are uses drugs. So that falls in those three categories, right? Positive test results, that's 44 and 90. Those subject uses drugs are 44 and 6, and we cannot count one category twice. So that's 44, 90, and 6, right? So that's 44, 90, and 6, right? So that's what? 96, that's 140 over 1,000, that is 0.14. Right, so that's intuitively, right? If we use formula, right? The probability positive or uses drugs, that is the probability of a positive result plus the probability of uses drugs minus those who are positive and uses drugs. Right. So positive, I do not care about what's in the middle, right? Just find, well, how many are positive test result, right? That's 134. Those who use drugs is the row, right? That's 50. And take away the overlapping, that's positive and uses drugs. That's this 44. Oh, wow, let's go covers the number. Wow. Yeah. All right. 44. All right, good. That result should still remain the same number. 134, 50 minus 44. That should be 140. Okay. So no matter you do it by formula or intuitively in this question, should be the same result. And maybe not a good idea to write a blue color on the blue color. To put extra space on the bottom. Yeah. 0.14. All right, good. Nice. Okay. So that's both use formula and intuitively. All right, this question, right? This question, like the table, we are able to do by either formula or intuitively. Some other question may be not that clear. Right, go back to pick a card. Right. Randomly pick one card from a well-shuffled deck of cards. Find the probability that it's an ace or a diamond card. Right, so probability that is an ace or this is a diamond. Right, so even though we have the chart here, it will be a little bit hard to count everything. So we use formula to do, right? To get an ace plus probability to get a diamond card minus the probability you get an ace diamond, which is a diamond ace, right? That's 4 aces in the well-shuffled deck of cards. That is 1 suit out of 4 suits, but together that's 13 cards out of 52. One suit is 52 cards from ace to king, right? You can see that. Diamonds from ace to king, that's 13 cards. Ace is 4 cards, right? And every deck of cards will only have 1 card that is a diamond ace. Right, so take away 1 of the overlapping. So we get what? 4 plus 13, that's 16, right? Minus 1. So 16 out of 52 is what? 0.3077. Right, if you leave answer like 16 over 52, that's also fine. If you keep as decimal, that's better for me to grade your work. Okay. Okay, so probability it's a spade or a red card. Right, so use formula, right, to get a probability of spade plus the probability of a red card. If you know your card well, right? The spade is black card, right? They have no overlapping with the red cards, right? So whenever you get a spade, you cannot ever get the card is red. So somehow they are mutually exclusive, right? Which nothing to be subtract. Doesn't like there exist the diamond ace. That doesn't exist a red spade card. So what we have just the sum, right? That's one suit is spade, two suit is red to get three suits possibly over four suits, or that's 13 spades. That's 26 red cards. And that's 39 out of 52, which is 3/4 of the total, right? 0.75. I don't need to use calculator to double check, right? 39 over 52, right? That's 3/4. Okay. Right. So that's what we have. Right. The next question. X1 be the face value of the first die, Y be the sum of two dies. I find the probability that x1 is equal to 3 or the sum is 5. Right, so just use formula plus the sum to be 5 minus the case that the first die is 3 and the sum is 5. Right, so for this question, what we need is to see, well, since the first die is 3, that's very clear, right? The first die is 3, that's just those 6 outcomes. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. I mean 3, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6, sorry. And how do we get the sum to be 5? That is the tricky here, right? Sum to be 5, that the die is 1, 4, or 2, 3, or 3, 2, or 4, 1. Right, from the rolling two dice. 1, 4 give us the sum to be 5. 2, 3 is also sum 5. 3, 2 is a sum 5. 5, 1, 4, 1 is a sum of 5. Right, we see that in our last section that is dealing with probability distribution. Right? So that's 6 outcomes in 36 total. The sum to be 5, we have 4 possible outcomes of 36 total. And what? First die is 3, the sum is 5. Actually, we have that case, right? We have that one case to be that. So that's 4 plus 6 minus 1, that's 9 out of it. And 9 over 36 is a quarter, that's 0.25. Right, the second one, the sum equal to or sum equal 4, probability y equal 2 plus the probability of y equal 4. Is that possible, right? No, it's not. Are they overlapping? My question, not I want to ask that. Why are they overlapping, right? The sum is 4 and the sum is 2. Maybe I use another color. Y is 2, that is what? Y and 1, right? The sum is 4, that is what? 1, 3, 2, 2, and 3, 1. Can they happen together? Two dice have sum of 2, can never have the sum to be 4, right? So they cannot occur together. So That is what? 1 over 36, 3 over 36. That's 4 out of 36, which is, let me draw the boundary. Okay, 4 out of 36. That's 19. That's 0.1111. Right, let me have another boundary here and use another color. Right. The sum equals 7 and the sum equals 12, right? From the last thing we can see, right? When sum is 1 cannot be another, right? Sum to be 7, we have what? 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and the 6, 1. When sum is 12, that's only the case of 6 and 6. They can never occur together at the same time. So impossible to have, wow, even I cannot write 0. Impossible to get this event, right? Impossible. Right, so that's everything in this section. The intersection of events and union of events, right? Thank you.